Let me start by saying, for example, 2, that the picture you see should have been included in the statement. Had we been meeting face-to-face, this would have been drawn on the board for you. But this is a cube that has 6 faces, right? 1 to the right, 1 to the left, 1 to the top, 1 to the bottom, 1 to the front, and 1 to the back. So in each direction there's 2 X faces, 2 Y faces, and 2 Z faces. And we can let dA be a differential area element. Then the flux can be given by the integral of E dotted with dA, which is the same as the integral of 3x I hat plus 4j hat dotted with dA. And now, depending on which face we're talking about, dA could be in the x direction, y direction, or z direction. So let's take a look at the right face first. For the right face, which is this shaded part here, the dA is going to be in the positive x direction, so it's dA I hat. So phi sub E is going to equal the integral of 3x I hat plus 4j hat dotted with dA I hat. And as we know, when we do the dot product, only like terms survive. So this is going to be the integral of 3x times dA, which is the same as, since the 3 is constant, 3 times x dA. And we know for the right face, x is constant at 3 meters. So this means that phi sub E then is going to be the integral. If x is 3, I can move this out and it becomes 9 dA. And if I integrate the area, the differential element of area, I'm going to get 9a. Right? So if we want to find the flux at the right face, we note also that this is a cube of size 2, right? Because it's going from x equals 3 to x equals 2, so all of the sides are 2, which means this is 9 times 2 times 2, which gives us 36. And the units for flux are Newton meter squared per coulomb. So for the right face, we get this value. Note for the left face, we get the same. Except that the x value is 1 on the left-hand face, and that dA vector is minus dA I hat, so we become a negative side because dA for the left-hand side, which is this, is pointing that way, which is in the negative x direction. So let's put this as phi e sub right. This would be phi e sub left is going to be, again, the integral of minus 3x dA, which is equal to the integral of minus 3 times 1, because that's what the x value is at the left-hand face, times dA. So this is minus 3 integral of dA, or minus 3a. And again, a is 2 times 2, so this is going to be minus 12 meters squared per Coulomb. We're asked for the top face now. So for the top face, which would be what I'm going to draw in red, would be this one. Notice that dA is pointing in the positive y direction. So this is going to be phi e t for top is going to be, again, the integral 3x I hat plus 4 j hat dotted with dA, right? Which is going to be, in this case, 3x I hat plus 4 j hat dotted with dA j hat, so only the j hat in this case survives, and I get the integral of 4 dA. And if I move the 4 out, I get 4 integral dA. So this is 4a, or 16 Newton meter squared per Coulomb. Note, since J component of E is constant, then the flux through the bottom surface is also going to equal 16 Newton meters squared per Coulomb, but it's going to be a negative because, again, if I draw this in red, it's going to be this surface now, and dA now is pointing in the negative y direction. Also notice that in the z direction, so the front and back faces, so also note for front and back face, dA equals plus or minus dA k hat, which means the flux is 0 since we don't have any components in the k direction for the electric field. So that will be the end of part A. Part B says, what is the net charge? So we know that the net charge is related to the flux by Gauss's law. And it says that the flux is the charge enclosed in the Gaussian surface over the epsilon naught, which means that the charge enclosed is is epsilon naught times the flux, and the flux total is going to equal flux right plus flux left plus flux top plus the flux on the bottom plus the flux to the front and the flux to the back. And we already know these are zeros, so we get our 36 Newton meter squared per coulomb plus a negative 12 Newton meter squared per coulomb plus a 16 Newton meter squared per coulomb minus 16 Newton meter squared per coulomb. So I get a flux total of 24 Newton meter squared per coulomb, which means that the enclosed charge is epsilon naught, which is 8.85 times 10 to the negative 12 coulomb squared per Newton meter squared times the flux, which is 24 Newton meter squared per coulomb. Notice the newtons cancel, the meters squared cancel, one of the coulombs cancel the square, and you get 2.1 times 10 to the minus 10th coulombs.